today's course, you're going to learn how to build an application just like Squibble AI. This application is called Soda MCP. Soda can work alongside Claude Code, which is exactly what I did in Squibble AI. Now, Soda is even better because it can test features end to end using browser automation tools. So that means it can open the browser, it can take screenshots, it can click on elements, it can also read the DOM structure, including console logs, so it can help developers debug and also fix broken features. I guess it pretty much replaces a QA on your team. Another awesome feature in Soda is it can take screenshots of the browser and then compare your designs to your mockup. So at all times, you're gonna have beautiful, perfect designs. Now, the best part is you can connect Soda AI to a front-end application like a Kanban board, so Soda can create tickets, update their statuses, read ticket features, and test accordingly. So you can document the whole process and also keep track of every single stage. Now, because we're using clerk authentication, we also have clerk billing. So you can wire up feature gates inside the MCP so that when Claude Code is communicating to either create a ticket or create multiple tickets, you can check to see if the user can create those tickets or not. Now, if you want to save time and get access to the entire code base, I'm going to leave a link in the description down below. Now, as a bonus for grabbing the code base today, you're also going to get an example front-end application, which is a Kanban board that can show you what this looks like in action. And yes, I've also added a limited time discount that you will see at checkout. And if your country qualifies for it, you can get access to a PPP discount. Now, if you find these videos valuable and you'd like to see more of these on your feed, then please consider subscribing. That is the single most free thing that you could do for us that's going to help us grow this channel and provide more free value just like this. This blueprint can help you build any MCP of your choice. The transport layer connects your MCP to Claude. Authentication ensures that every request goes through a verification process, along with any feature gates. The protocol layer manages routes, and tools give Claude the ability to perform actions through our services. This file is the transport layer. It's a route that bridges between Claude and your server. We are using server-sent events, or SSE, because MCP requires bidirectional communication. Claude will send post requests to us, and we will push responses back through a persistent SSE stream. Think of it like a phone call where Claude talks through post and we respond through the open line. Let me show you how this works. Before we write any endpoints, we need to solve a problem. When Claude connects, it opens an SSE stream. When Claude sends a message, it comes through a separate post request. How do we link these two together? The answer is sessions. We declare a global map that will store every active connection. The key is a session ID, and the value contains everything we need to respond to that session. We attach this map to global this, because in serverless environments like Versal, your code might run across multiple requests in the same instance. By using global this, our sessions persist between requests instead of being reset every time. Now, let's create the get endpoint. This opens the SSE stream. First, verify the user. Next, we generate a unique session ID. Then, create the SSE stream and send Claude the endpoint URL. Store the session in our map with the send function, and finally, return the stream with the event stream content type. Our post endpoint is the other half of the connection. Remember, SSE is one way. We can only push data to Claude. So when Claude wants to call a tool or send us a message, it needs a way to talk back. That's what post is for. Claude sends requests here, we process them, and push responses through the SSE stream we stored earlier. So we just built the SSE route that handles session management in this project. Now, in the next few minutes, I want to show you how you can maintain this product in the long run if you choose to use AI to build on top of this. Now, one of the most common problems I've seen when I use Claude Code, and this also is the same thing for Cursor and every single LLM, it doesn't really matter, is that sometimes it forgets about the context. Now, obviously, that's because we have a context window. And so what ends up happening is you have two different architectures and it duplicates this again and again. And now Claude Code or whatever AI ends up sort of trying to manage both of these architectures. Now, obviously, over time, you can imagine the chaos you're going to create, right? And so I want to show you how you can leverage free AI tools to give you code suggestions, analyze your code, review everything, and tell you if this has happened in the code base. So I'm sure you guys have heard about this tool. It's called CodeRabbit. And CodeRabbit by far is the best AI reviewing agent I have found in the market. And it's absolutely free. If you use a link in the description down below, you can get a free account and you can try this out. But in this video, I just want to show you how you can set it up and what awesome features it has so you know exactly how to use it. So the first way you can get CodeRabbit inside your code base is through the plugins, right? The plugins page right here inside Visual Studio Code. Once you install the plugin, you can just click on review all changes, and that's going to review everything, and it's going to give you code suggestions directly inside your code. Another way, which is my favorite way, is doing it directly from GitHub. And the way to do that, guys, is to go ahead and click on login and create your account, or you can use a link in the description, and that's going to take you into your dashboard. Obviously, you don't have repositories and all that kind of stuff connected yet, so go ahead and sign in with GitHub. Now, when you sign in with GitHub, just make sure that you give it all access to all repositories. Now, I prefer this. It's up to you. I like this because I don't want to go into my, CodeRabbit dashboard and keep changing things over and over again, right? Do that once so you never have to do it again. Once you connect your repositories, you're pretty much set. And that's when it will kind of look like this. And now you can select the repositories if you like, if you need to give it permission. Whenever you create a pull request, CodeRabbit will automatically reference itself, and it's going to read the entire pull request, analyze the files, give you like a summary of every single thing. So if you have a code reviewer in place, you can just imagine how much time you're going to save them, and it's free to use, right? So I like this, not just because of the summary and understanding what my team members are actually pushing. I actually like this a lot, which is the sequence diagram. So if you like visualizing your code and seeing how all the functions and all the things you created connect between each other, you can look at the sequence diagram, and it's a full, kind of like a full markdown as to what exactly is happening inside your PR. You can also mention CodeRabbit in the comments and tell it what you want it to do, and it can fix that there itself. It'll give you code suggestions. And sometimes if it catches a potential issue, it'll also give you code suggestions there as well. Now, if you are a tech nerd, you might be familiar with a CLI. And so if that's what you're comfortable with, you can also run CodeRabbit directly in the CLI as well, okay? So that means you can run this in the CLI and also let Claude Code know about it. And so both of them can communicate with each other. So think about this. What if you used CodeRabbit plus Soda AI, and you use Claude Code to also review? You would essentially have flawless code. And not to forget, thank you so much to CodeRabbit for sponsoring this video so that we can create more free resources just like this. So go ahead, grab the free link in the description, and start using AI to build your next project. Great. Now that we have learned how to create a connection between Claude and our server, let's understand how to authenticate the user on every request Claude sends. Remember authorize MCP request from the SSE route? That was just a placeholder, and now we're going to build it. Let me show you what we're working toward. When you run Claude MCP add with our SSE endpoint, Claude adds the server, but authentication fails, which is expected since we haven't built it yet. You type /MCP, select the failing server, hit re-authenticate, sign in through the browser, and now you're connected with 18 tools ready to use. To make this work, we need OAuth with PKCE, because CLI apps can't store secrets safely, and PKCE uses a hash challenge instead. Claude sends a hash challenge, our server checks clerk auth, you sign in, we create a signed auth code, Claude exchanges it for a token, and that token is what authorize MCP request validates on every request. The token starts with MCP underscore, the middle is base 64 JSON, containing the user ID and expiration, and the end is the HMAC signature, which proves authenticity without needing a database. Now for the implementation, everything lives in mcp-auth.ts, organized into 3 sections for types, creation, and verification. MCP user defines the shape of an authenticated user, including their internal ID, clerk ID, email, and name. Create MCP token takes a user ID, builds the payload with expiration, signs it with HMACSHA256, and returns the prefix token. Verify MCP token splits the token, recomputes the signature, and uses timing safe comparison to prevent attackers from guessing bytes. Validate MCP token is your main entry point that authorize MCP request calls. MCP tokens get verified internally while other tokens fall back to clerk. Extract token handles the authorization header, supporting both bearer prefix and raw token formats. We've built the token system. Now we need 4 routes that Claude actually calls to get authenticated. First, discovery. This is just a config file that tells Claude where everything lives. One request, and Claude knows all your endpoints. Second, registration. Claude introduces itself, and we give it a signed ID. No database needed. The signature proves it's legit. Third, authorization. This is where you sign in. We check if you're logged into Clerk, and if not, we send you to the login page. Once you're in, we create a signed code to prove it. Fourth, the token endpoint. Claude exchanges that code for an access token. We verify everything matches up and hand back a token that works for a full year. Let's see the code. Discovery is dead simple. Just return your endpoint URLs as JSON. Claude reads this once and knows where to go. Registration takes Claude's callback URL and returns a signed client ID. The signature lets us verify it later without saving anything. The authorized route checks if you're signed in with Clerk. If yes, we create a signed code and send you back to Claude. If not, you hit the login page first. Token exchange is the last step. Claude sends the code, we verify it's real, and return an access token. That token is what gets checked on every request from now on. Great! You now know how to set up a complete auth flow. Claude can find your endpoints, register itself, sign users in, and walk away with an access token. In the next module, we're going to learn how to handle what Claude sends you. Alright, so authentication is done, which means Claude can now actually talk to our server. Here's how the conversation works. Every time Claude sends us a message, that message has 3 parts. First, what Claude wants to do. Second, the details it needs to do it. And third, a number, so we know which message to reply to. Now Claude will ask us 4 different things. It might say, hey, let's connect to start the conversation. It might ask, what can you do, to see what tools we have. It might say, do this thing for me, when it actually wants to use a tool. Or it might just ask, are you still there, to make sure we're alive. And our job is pretty simple. We read what Claude wants, we do it, and we send back the answer. Alright, let's look at the actual code. This is our message handler function. It's basically just checking what Claude asked for, and then doing the right thing based on that. When Claude says, let's connect, we reply back with who we are. We tell it our name, our version, and that yes, we do support tools. When Claude asks, what can you do? We send back a list of all our tools. Each tool has a name, a description of what it does, and what information it needs to work. When Claude says, do this thing, that's where the real work happens. We grab which tool it wants, grab the details it gave us, run the tool, and send back whatever happened. And if something goes wrong, we catch the error and send that back instead. Every single reply we send follows the same pattern. We include the number that Claude sent us, and then either the answer or what went wrong. But here's the thing. Right now, when Claude asks, what can you do? We're sending back an empty list, and when it says, do this thing, we don't actually have any tools to run yet. In the next module, we're going to create actual tools that Claude can use. Now let's look at the real tools powering this MCP application. We've got two main categories: browser tools for automation and ticket tools for managing work. We'll get to the ticket tools later on. For now, let's understand how we can make our MCP app test features start to finish through the browser tool. Our tools give Claude the ability to test tickets and features in our application. The awesome part of this app is we built our own browser automation layer. It's called the Browser Manager, and it uses Playwright under the hood to simulate testing. Browser Manager is a singleton. That means there's only one instance running, and it manages a single browser that stays open across all your tool calls. So when Claude calls navigate, then click, then screenshot, they're all talking to the same browser window. This helps us automate QA testing for features in our apps. First, Claude calls one of our MCP tools. That tool calls a method on Browser Manager. Browser Manager uses Playwright to actually do the thing. For example, open the page, click the button, take the screenshot, and more. Then we send this result back to Claude. Let me show you the code. Here's our Browser Navigate tool definition. We give it a name, a description, and a schema that tells Claude what parameters it needs. In this case, just a URL. And here's the handler. When Claude calls browser navigate, we grab the URL from the arguments, call browsermanager.navigate, and send back the page title and URL so Claude knows it worked. The screenshot tool is even cooler. Claude calls it, Browser Manager grabs the current page, Playwright takes the screenshot, we encode it as base64 and send it right back. This way, Claude can actually see what's on the screen. Claude tells us what element to interact with using CSS selectors. We call the Browser Manager method. Playwright finds the element and does the action. We report back what happened. Now let's look at the ticket tools. When Claude creates a ticket, we grab the title, description, priority, and tags. From the request, we pass that to our ticket service, which handles all the database work. Then we send back the created ticket data. Same thing for updates. Claude sends the ticket ID and what to change. We validate, update, and respond. Simple. You can also use Zod here to protect the endpoints further. But here's where it all comes together with this test ticket tool. When Claude wants to test something, it doesn't just run one tool. It runs a whole sequence. Claude sees every response and decides what to do next. It can also create tickets, modify them, mark them as completed, read feature scopes, and more.
What's up, Prodigies? If you're still watching this video, it means you found this valuable and you're ready to take this to the next stage. And if you're wondering what's next, it is connecting a front-end application to an MCP server so that Claude Code can use the MCP and communicate with their front-end application. Now, learning how to do this is going to be the most valuable skill you can have in 2026 because most developers have completely moved towards AI coding. And most tech companies like Neon, Convex, and Figma use MCP servers to drastically improve the developer experience. So developers now can directly communicate with the application without needing to actually go into the app. But the best part is they don't have to do this. AI can. And that's why I thought learning how to connect the two is going to be super valuable because I myself couldn't find that on the internet. So if you use the link in the description down below, you'll get access to all the code we've already seen today in this course, along with this bonus front end and all the code required to connect it to the MCP along with Claude Code as well. So if you choose to buy the code base today, I'm going to add a nice discount that you will see at checkout. And if your country qualifies for this, I've also added a PPP discount for your country, and you can get that discount on top of the already discounted product. All right. Hope this helps, and thank you so much for choosing to grab the code base. I wish you the best, and I'll see you in the next one.